The last part of this revision topic, we want to talk about what happens to the energy levels during state change. Okay, so let's say we start as a solid. Okay, I know the particles are very closely packed. This is how they look like. So as I heat it, the energy is transferred in, and the particles move more and more, vibrate more and more vigorously. So what will happen is the internal kinetic energy level will increase. Okay, and if the internal kinetic energy level increase, then my understanding is the temperature will also increase. This is what is observed over here. As I heat up, the temperature will rise, and the reason is because the particles move more vigorously, the internal kinetic energy really increases, and since temperature is a measure of the average kinetic energy, the temperature will rise. Okay, then we will reach a stage where the substance will start to melt. So is trying to change state from a solid to a liquid state. Over here you can see some particles are still very close together. Some particles start to move further apart already. So during this process, right, I also have solid and liquid existing at the same time. Now the heat is still supplying energy. So what is this heat energy used to do? Is it used to increase the kinetic energy level? The answer is no, because the particles are trying to move away from each other. Right? So when they try to move away from each other, it is the internal potential energy that is going to increase. The energy is not used to increase the vibrational movement of the particles. Okay, so since there's no increase in kinetic energy, the temperature, as you can see over here, remains constant. Okay, the energy is used to increase the internal potential energy because they want to overcome the forces of attraction between the particles. Okay, so during the melting process, temperature remains constant. Okay, so during state change, no change in temperature. Then once all the substances have melted, then I will get all liquid. So you can see the liquid here, the particles are slightly further apart. The flame continues to supply energy. What is the energy used to do? The energy is used to increase the speed at which the particles slide over each other. They move about more and more quickly. So once again, the internal kinetic energy level will increase, and therefore the temperature increases, as you can see over here. Temperature increases. Okay, the temperature will increase until a stage where the particles will start to move away from each other once again. This process is called boiling, moving from a liquid state to a gaseous state. So during this process, I will see some particles close to each other. I will see some particles far apart. So I will get both liquid and gases during this state change. Okay, and during this state change, the energy is still being supplied. What is the energy being used to do? The energy is used to overcome the forces of attraction and move the particles further apart from each other. So since the particles are further apart, the internal potential energy increases. Okay, the kinetic energy level do not increase, and that is why the temperature remains constant. Alright, so this process will carry on until all the liquid has boiled off, and during this process, temperature remains constant. Then what happens is once all the liquid has boiled off, I will only have gases. Okay, you can see that the gases are far apart. Okay, and heat energy is still being supplied. Now what is happening to these particles? They are going to move about randomly at high speeds, and when they receive more energy, they are going to move even faster. So the internal kinetic energy of the particles increase, and therefore the temperature also increases. Alright, so over here you can see that from solid to liquid, the volume doesn't change much. Okay, but when I move from a liquid to a gas, the amount of space they occupy suddenly increases by a lot. Why is that the case? Because the particles are far apart. Alright, this can also show you why gases can generally be compressed, because there's a lot of empty space between the particles.